Given is a matrix A of third order, a squared matrix of third order, and we have to verify A cube minus 6A squared plus 9A minus 4I equal to a zero matrix, and hence find A inverse. That is using this result and not using that A inverse is 1 by determinant A into adjoint A. Never do that method if it is written hence find A inverse. That means first prove the result A cube minus 6A square plus 9A minus 4I equal to 0, and then proceed finding A inverse. Now to find this result, to prove this result, let us work out A square and hence A cube and then substitute in the left hand side of 1. Let me call the result to be proved as 1. So first of all work out A square, that is A into A. What is the given matrix A? 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 multiplied by the same, that is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. And you know how to multiply, that is the elements of the first row to be multiplied with the elements of first column. And the required matrix, the product will also be a matrix of order 3 by 3. So you get 2 into 2, 4, and minus plus 1 and plus 1, repeating the process of multiplication of first row with the second column. You get negative 2 again, and negative 1. And then multiplying to the third column, you get 2 into 1, that is 2, and negative, you get plus 1, and 1 into 2, you get plus 2. Similarly, then you repeat yourself, multiply the elements of second row with the first column, second column, third column. You will get, here negative 2, negative 1. Multiplying to the second column, you will get 1 plus 4 plus 1. And to the third column, you will get negative 1, negative 2 again. And now repeat the same process with the third row. With the third row, you multiply the third row with the first column, second column, and third column. You will get 2 plus 1 plus 2 minus 1 minus 2 minus 2 1 plus 1 plus 4. Now just work it out and you get A square equal to a matrix of third order. The elements are 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6. Okay, so you have worked out A square. Let me check. 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6 here. And now to find A cube. How do you find A cube? Take it as A square into A. You have A square with you as 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6 multiplied with the given matrix A, which is defined as 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Multiply the 2 and you will get a matrix of order 3 by 3 again. By now you know very well how to multiply. Multiply the elements of first row with the first column. You get 12. You get 12 plus 5 plus 5. Repeat the process with the second column. You get negative 6, negative 10, negative 5. And then with the third column, you get 6 plus 5 plus 10. Then you multiply with the second row to the elements of first column, second column, third column, and you get negative 10, negative 6, negative 5, and so on. And similarly with the third row, I leave for you to try this. And finally, after working out, you get the value of A cube equal to the matrix 22 minus 21 21 and minus 21 22 minus 21 and elements of the third row are 21, minus 21, 22. Okay, so now once we get a cube and a square, now just consider the left hand side of the result to be proved equal to 0 matrix. So what is the left hand side of the result to be proved? It is a cube minus 6a square and plus 9a and minus 4i. So let us substitute the value of a cube and a square, a and I. The value of a cube just now you worked out is 22 minus 21, 21, minus 21, 22, minus 21, and 21, minus 21, 22. Minus 6 times, you already know the value of a square is 6 minus 5. Please check the value of a square. 6 minus 5, 5, minus 5, 6, minus 5, and 5 minus 5, 6. And plus 9 times the matrix A, given matrix A, which is 2 minus 1, 1, minus 1, 2, minus 1, and 1 minus 1, 2. And to this you add minus 4 times the identity matrix of third order, which is 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1. Now multiplying by the constants outside the matrices, keeping a cube as such, which is 22 minus 21, 21, you can write the rest of the elements of a cube yourself, and plus multiplying by negative 6 to the elements of a square, you get negative 36, 30, negative 30, 30, negative 36, 30, negative 30, 30, negative 36. And work out the value of 9 times a, so you get plus 9 times a, you get 18 minus 9, 9, minus 9, 18, minus 9, 9, minus 9, 18. And multiplying with negative 4 to the identity matrix, you get negative 4, 0, 0, 0, negative 4, 0, 0, 0, negative 4. Now, all the 4 matrices are of the same order, that is 3 by 3. So if you add them, you will get, see, at least the first entry I write here, it is 22 minus 36 and say plus 18 and minus 4. So you get 18, 22 plus 18, that is 40, and minus 40. Similarly, you just write all the elements here and add them up. So you will get 0, 0, 0, 0, 0, 0, 0, 0, 0, a 0 matrix of 3 by 3 order, and that is the right hand side of the required result. But before I end, there is a second part. Using this result, which result you have proved by now? We have proved that a cube minus 6a square plus 9a minus 4i equal to 0. Now further in the question he says, hence, please make a note of this term, hence find a inverse. And not independently, I repeat again, using the formula 1 by determinant a into adjoint. So to find a inverse using this result, post multiply each term on both sides by a inverse. Post multiplying each element, each term with a inverse. So you get a cube, if I may rewrite as a square into a inverse, and a into a inverse in one bracket. Similarly, a square I can split as a into a, so minus 6 times a into a inverse. So I just miss one step and write bracket properly. Similarly, 9 times a into a inverse and minus 4i times a inverse equal to 0 into a inverse of 4, 0. And now I'll use certain results that a into a inverse is identity matrix, and A inverse, I into identity matrix is A inverse, and similarly A into identity matrix is A. So using all these results, you get A square A into A inverse is identity matrix, again A into A inverse is identity matrix, and 9 times A into A inverse is identity matrix, minus I into A inverse 4 times A inverse equal to 0. And now you know A square into identity matrix is A square, and minus 6 times A into identity matrix is A, and plus 9I and minus 4A inverse equal to 0. So from here, do you find the value of taking like 4A inverse on the right, etc.? You get the value of 4A inverse as A square minus 6A plus 9I. We already know the value of A square, A and I, so substituting these values, we get 4 times A inverse equal to, we worked out A square. You already know the value of A square. What is the value of A square? 6 minus 5, 5, minus 5, 6 minus 5, 5 minus 5, 5 minus 5, 6. Okay, and minus 6 times A, the given matrix, which is 2, minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2, and plus 9 times the identity matrix, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. And if you work out, you get 4 times A inverse equal to the value of A square, you keep it as such for a moment, so you get 6 minus 5, 5, and rest of the elements are minus 5, 6, minus 5, and 5, minus 5, 6. Now in the second term, multiplying each term with negative 6, you get negative 12, 6, negative 6, and 6, negative 12, 6, negative 6, 6, negative 12, and 9 times the identity matrix will give you plus 9, 0, 0, 0, 9, 0, 0, 0, 9. Now all the three matrices at this stage can be added, being the matrices of third order. So it was 4 times A inverse. So what will be A inverse? 1 by 4 times the matrix obtained by adding the 3. So what do you get? At least the first term is 6 plus 9, 15 minus 12. So that step I leave for you to try, that you add all the 3 elements respectively first, and finally you will get 3, 1, negative 1, 1, 3, 1, minus 1, 1, 3. So this is the value of A inverse as 1 by 4 times 3, 1, negative 1, 1, 3, 1, negative 1, 1, 3, which is the required result.